So this is Unit 9, Lesson 2, and it's on law of sines, which you may have done last year in geometry because it was one of the additional topics for Common Core geometry. But if you did, it probably was done towards the end of the year, when you guys didn't have a ton of time right before your early Regents. So we're going to go over law of sines, which is on the reference sheet. The formula for law of sines is on your reference sheet for the old Algebra 2 exam. Now it says in the last lesson, which we didn't do, we found a very simple formula for calculating the area of a triangle. That formula, which also is on the reference sheet, is K equals 1/2 AB sine C. The formula can be manipulated to produce what is known as the law of sines. Now, there's 3 different ways that we can express the area of any triangle. It doesn't have to be this, 1/2 AB sine C. It could be 1/2 BC sine A, or it could be 1/2 AC sine B. The main thing is, whatever angle you use, like if you're using angle A, like we were in this case here, the 2 sides that we use, B and C, have to fall on either side of that angle that we're using. Okay? So again, the sides that we use have to be on either side of that angle. And actually, I'm looking ahead now really quickly, we're going to do area of a triangle later in a lesson, so sort of interesting. Should have done that lesson first. But anyway, that's a little bit of a side note. Now it says, write an extended equality, more than one equal sign, that relates the 3 expressions from part A. So if I did 1/2 AB sine C equals 1/2 BC sine A equals 1/2 AC sine B, because they're all representing the area of that same triangle, and then I divide each side of the equation by 1/2 ABC, so divide this and this and this by 1/2 BC, 1/2 ABC, 1/2 ABC. This will cancel, this will cancel, this will cancel. We'll get sine C over C. Here, this will cancel, the B and the C will cancel. We'll get sine A over A. And then here, the 1/2, the A and the C will cancel. We'll get sine B over B. Which again, this is the formula that is on your reference sheet on the Regents. So, oops, my computer's freaking out. Come on, scroll down. Give it a second. So you can see in the box below it says law of sines, sine A over A, sine B over B, sine C over C. This is provided for you on your reference sheet. You also could use all the reciprocals. It's the same thing to put the sides on the top and the sine of the angles on the bottom. So let's look at number 2. It says in the triangle below, you have all that information given. Determine the lengths of AB and AC to the nearest tenth. So I'm going to call AB X and AC Y. AB will be X, AC will be Y. I'm going to work on finding AB first. Now, the one thing that I always focus on when we're doing law of sines is having a pair. And what I mean by a pair is an angle and the side opposite it. So we have that with angle A and side A. I have this angle, but I'm looking for that side. So I can set up law of sines where I say X over sine of the angle opposite it, which is 68, equals 16 over sine of the angle opposite of that, which is 80. And I'll wait a second to solve that, because now I'm going to set up the proportion for y. Now if I want to find y, again I have this pair, the 16 over the sine 80, equals, then I have y over the sine of 32. Now, when you want to solve this, it's a proportion. We cross multiply. Put this down just a little bit. We're going to get x sine 80 on the one diagonal equals 16 sine 68. Divide both sides by sine 80. Just make sure your calculator is in degree mode, and you get to the nearest tenth, 15.1. When you cross multiply and solve this one, which if you want to pause me for a second so that you can actually try it, you get 8.6. Okay? So this is the length of AC. This is the length of AB. Pretty easy. Go on to the back. We're going to do another one. A triangle DEF below, they give you all the information, and that's already in the picture. Find the length of DF in exact and simplest form. So that's going to be important, exact and simplest form. Exact means we will not round. You're not going to use your calculator to round anything. So again, we have this side of 20 and the angle opposite it of 30. So 20 over sine 30 equals this side of x over sine of 45. Now when we cross multiply, we're going to get 20 sine 45 equals x sine 30. The problem is this word exact. It's really messing us up. Because if you type this into the calculator, it's going to give you some ugly non-exact number, some decimal. So you should remember from your work with trig what sine of 45 is. Hopefully you guys remember your 45, 45, 90 right triangle. And if we're working on the unit circle, our radius is 1. The sides for the 45, 45, 90, square root of 2 over 2, square root of 2 over 2. So sine 45, you should remember, is square root of 2 over 2, because that's the y value of that triangle. And then sine 30, we need a different triangle for, 30, 60, 90. Again, it's on the unit circle, so 30, opposite that is a half. Square root of 3 over 2 would be opposite the 60. But again, we're trying to get sine of 30, so we want the y value, not the x. So it would be x times 1/2. We could do some simplifying here. 20 times square root of 2 over 2. 20 over 2 is 10. Oops, that's an ugly 10. So you get 10 square root of 2 equals 1/2 of x. And the easiest way to get rid of that half, rather than dividing by a half, is to multiply by 2. So you're going to get 20 square root of 2 equals x. And that is our exact answer in simplest form. So that was a little tough because we couldn't just plug it into the calculator like the last one. All right, let's look at the next one. Again, they give you a bunch of different values. They want you to find angle I. So take a second and set up the proportion. Again, 12 should go over sine of 25. 26 should go over sine of whatever angle I is, which we don't know. So we're still going to cross multiply. 12 sine I equals 26 sine 25. I want to get I by itself, but it's attached to the word sine, so I could divide by 12. So I get sine of I equals, I'm going to throw this in my calculator and see what I get. 26 sine, oops, I went to the wrong thing. Let's go back here. Where is my calculator? It closed itself. So when I plug that in, I get 0.91567, etc. Now the thing is, that's what sine of I is equal to. It's not what angle I is equal to. So hopefully you guys remember that after that, you have to do inverse sine of that number, 0.91567, whatever. And you end up getting to the nearest degree, or nearest tenth of a degree, 66.3 degrees. Don't mess up on rounding. It's one of the silliest things to get points taken off for. Make sure you're paying attention to where they're asking you to round to. All right, now this last one, number 5, pretty tricky because it's got kind of 2 triangles in one. Did they fill in everything they gave you in the problem? I believe so. The 20 degrees, the 115 degrees, 90 degrees, and CD is 18. Yeah, so everything is there. What do you want to find? Determine the length of AB to the nearest tenth. Note that you will need to apply law of sines twice to solve this problem, which technically is not true. You could maybe do SOHCAHTOA as well, but we'll see. Now, what I usually try to do first is find anything that I can. For example, in this triangle, we have 2 angles of 115 and 20, which gives you 135. 180 minus 135 gives you the remaining angle of 45 right here. And same type of thing here. You have a straight line, which is 180 degrees, so this will be 65. 65 and 90 in this triangle now leaves you with 25 degrees here. So we found all the angles. Problem is, in this triangle, which is the one that contains the x that we're trying to find, we don't know any of the sides. We only know information about the angles. But look at this triangle. We have this side of 18 and the angle opposite it of 45. We have this angle of 20, so we can find that side opposite it. So essentially I'm going to put a y right here and say y over sine 20 equals 18 over sine 45. And again, pause me if you need, but when you cross multiply and solve, you end up getting, and I'm not going to round this yet because this is not the answer that I actually want. It's just part of what I need to get to that x value that I'm trying to get to. So you end up getting 8.706411, etc. 8.706, etc. And now from here, you could use SOHCAHTOA, because that's a right triangle, or we can do log sines again. We now have that 8.706 over sine 90, 706,411, that number's in your calculator, so use that, equals x, which is what we're trying to find, over sine 65. Again, cross multiply and solve, and you're going to get 7.9 for your answer. Did they give you units, no feet or inches or anything like that? Nearest tenth, we did do nearest tenth, so we're done. Now again, you could have used SOHCAHTOA in this problem. If we did SOHCAHTOA, I probably would use this angle here and use opposite over hypotenuse. So you'd get sine of 65 equals opposite over hypotenuse. But look what you get on this diagonal. Sine 65 times that 8.706 number, sine 65 times that 8.706 number. The reason this works is because hopefully you remember what sine 90 is equal to from your unit circle. 90 degrees is up here at 0, 1. Sine 90 is 1. So that's why it's the same exact thing as doing SOHCAHTOA. So that's log sines. Hopefully you've seen that before, but if not, now you just got a little refresher on it.